Today we are talking about qualitative graphs. Okay, this is also talked about as graphing situations. Okay, so we're going to be talking about different situations involving time and distance or volume or amount of something. Okay, so we are going to be graphing situations. Okay, the graph displays the amount of cement in a cement mixer as it unloads. Okay, so talking about it unloading, which means the volume over time is going to be decreasing. Okay, and we can see that here in this graph. Okay, in each part of this graph, you can see we start to unload, but see how this line is really close to flat? This means it is unloading slowly. Okay, then this line gets a little steeper, so the speed increases. Okay, over time, the volume decreases quicker. Okay, then we have a flat line here. That means for this amount of time, the volume stayed exactly the same. So they stopped pouring cement, okay, at that point. All right. Then it continues at a constant rate until it is empty. Okay. Continues at a constant rate. All right. And I would say that rate is about the same as this second. You can see the slope looks very similar. It might not be exact, but it is at a constant rate. Okay. Now this portion here was at two different rates. Okay. We can see that there. All right. So when it is asking us to describe the change in volume over time, it decreased slowly to start, then was emptying at a faster rate, stopped for a period of time, and then continued emptying at a constant rate until it was empty. Okay, so that is what it's talking about. All right, now if we take a look at number 2 here, the graph shows the distance from the point of entry that Evelyn swims to warm up for a junior high swim meet. So if you think about a pool, okay, it's typically a rectangle, especially if you're at a swim meet. Okay, and it says distance from point of entry. So if we think about it, if she gets in here, she's going to swim getting further from where she entered, and then she's going to swim back in the exact same lane back towards her point of entry. However, as time increases, okay, we the graph has to move in that direction, right? Because time is not standing still. So she is moving away as time happens. Then she hits the wall. Her turn is not super fast. Then as she starts to swim, she swims faster. Then she hits the her starting wall again. Again, the turn is not as fast, and then she swims at a constant rate to the other side. So you can see at each of these, the turn is slow, and then she speeds up at a constant rate until she hits the wall. The turn is slow, and then gets up to her speed until she hits the other side, and so on. Okay, so these points where we have a point, that is where she hits a wall. Okay, where she starts, hits the far wall, hits her starting wall, and then back to the other side. This one's talking about the average wait time for callers on a tech line is shown on the graph. Describe the change in average wait time over the course of a day. Well, as you know, there are busy times and less busy times during a day when you call somewhere, or when you go to a restaurant, or when you do certain things. So we're talking average wait time here, okay? And it may be 5 minutes. We don't need numbers necessarily. It's a low wait time to start. That wait time increases as the day goes on. It hits a pretty high wait time, then increases to its peak wait time, and then decreases at a constant rate until probably close, right, where there's no wait time. okay, where they're closing. All right. So it, again, it's a steady, this flat part, these are steady where it stays the same. All right. And then these angles are increasing or decreasing at a constant rate. All right, I'll let you take a look at this one on your own. And there's a couple more here that you can try if you would like. Okay. All right. Now let's take a look at this one. Kira positions herself near the middle of a parade route so she can watch for a group called Playful Canines. Playful Canines begins the parade in a holding area, okay, at a specific place. Then its members march slowly and increase to a steady pace toward Kira's location. So start slowly and increase. So that's going to show, so if this is distance from Kiera, okay, they start away from her and they start slowly and increase to a steady pace. Okay, so that little bend there, okay, shows that slow and then that increase. Okay. And then it says till toward Kira's location where they stop to perform. So at Kira's location, they stop, time continues. Okay, so time continues, and then they move steadily away from Kira to finish the parade. So steadily is at a constant rate. Okay, they go back away from Kira. Now, this is a graph like this could also look something like this here, and then, oops, slow, steady pace, stops, and then away. It could look something like this as well. They don't specify how far from Kira the parade ends. Okay, it just says they finish the parade. So they might finish the parade at the same distance from where they start or at a lesser distance, but they go away from Kira at the end is the important part there. So some of these graphs can look a little differently based on how you draw it. Okay, and it says determine whether the graph is linear or nonlinear. Okay, well, we know linear means it's a line, and this obviously goes down and then back up. So this is a non-linear. And where the graph is increasing or decreasing, well, at the beginning here, it is decreasing. And at the end, it is increasing. And right here in the middle, it is staying the same. Okay, it is stable. Let's take a look and try another one. A roller coaster runs the same pattern. At first, it climbs a hill at a slow, constant rate. Then it moves quickly down the hill, the first hill, begins slowly as it ascends the second hill, speeds up again down the second hill, and slows at a constant speed until the ride ends at the starting gate. Sketch a qualitative graph to represent the situation. Determine whether the graph is linear, nonlinear, or where the graph is increasing or decreasing. So time is going to be on my x-axis, and that's going to continue the whole way. Okay. If we are doing speed of the roller coaster, it says the roller coaster rides the same pattern. At first, it climbs a hill at a slow, constant rate. Okay, so time goes on. We finally start, we're climbing at a slow, constant rate, and then it moves quickly and then slows at a constant rate and then moves quickly again and then slows all the way to the start again. So when we're talking about speed, we're increasing at a slow rate and then fast. We're increasing quickly, right? Then we're slowing and then we're increase quick and then we're slowing to the end. Okay? So when we're talking about speed, this is not talking about distance from anything. So we're talking about the top here would be the fastest speed, okay? And then here might be the starting speed where we're going up the hill, okay? And then we're increasing at that much faster rate where it slopes up, okay? And you can see that slowing and then back up again. And then we can see here it is increasing, decreasing, increasing, and then decreasing again here. Okay, and because it has multiple increases and decreases, that means we are non-linear on our graph here. Okay, it is, however, still a function, right? We can only hit one point on the graph because time continues forever. That is going to be a function. Okay. All right, here's one that you could try on your own. Okay, and another one if you'd like to try that. And then let's take a look at these. These have numbers on them, so our graphs are going to be a little more specific. Lisette is driving to meet her family in a neighboring city. Her initial speed on the highway is 50 miles per hour. Over the next 3 minutes, Lisette accelerates at a constant rate until her speed is 75 miles per hour. She maintains this speed for the next 32 minutes. And then an increase in traffic causes her to decelerate at a constant rate for 1 minute. Lisette then reaches a speed of 65 miles per hour and maintains this rate until she exits the highway. Sketch a graph to represent the situation. Okay, so there's a couple important numbers and things to mark on our graph, and then we can draw our lines at the end. Okay, her initial speed on the highway is 50 miles per hour. Okay, so we're going to start right here at 50 miles per hour. Okay, that's going to be our starting point. Then it says over the next 3 minutes, Lisette accelerates at a constant rate until her speed is 75 miles an hour. So 3 minutes. Well, this part here is 5, so it's about here. She gets all the way up here to 75. I'm going to put a little dot there because that's where we're going to get to. She maintains this speed for the next 32 minutes. So 3 minutes plus 32 minutes, we're going to end up at 35 minutes. So she stays the same here until 35 minutes. So I'm going to put another dot here at 35. And then an increase in traffic causes her to decelerate at a constant rate for 1 minute. Lisette then reaches a speed of 65. So she went down to 65 over 1 minute. That's going to be pretty close, which means she decelerated pretty quickly, and maintains this rate until she exits the highway. Okay, so she stays here until she exits the highway. So we're going to say she exits the highway about here. It doesn't specify exactly at how many minutes and then we're going to show her deceleration here uh, to a low number, somewhere around here. Okay, then I can connect my dots. Okay, and because she's moving at a constant speed on these, we can use a line. We can use a line to show these things. Okay. Now, if she was increasing her speed slowly or quickly or things like that, we would have lines that are not straight, but because she decelerates at a constant rate, she stays the same. Okay, this one here at the end, I might uh, go ahead and use a little bit more of a slopey kind of line. Okay, but putting these dots in specific places will allow you to make the graph most accurate. Okay, because they do provide you specific numbers. Okay, then we can see here this is an increasing spot. This one stays the same, so it's a steady rate. Okay, this is decreasing. We have the same again and then decreasing again at the very end. Okay, I'll let you try that one on your own. Okay, and this is creating qualitative graphs.